All right, guys, the property of equality with logarithms, probably the easiest one, but you do have to pay attention to the details with this one. So let's go ahead and look at number 81 and number 82, and those are going to be our examples. So the property of equality just simply says that if you have a logarithm and two logarithms really that have the exact same base, that's the detail. If they have the same base and they are set equal to each other, then the only thing you really need to pay attention to when solving is that x is equal to y, and it's in that statement. So if we look at number 81, the first thing I want to do is say, okay, we have an equality statement, and I'm going to look and I'm going to say, hey guys, the bases are the same. And because the bases are the same, all I need to do is pay attention to the values of these logarithms, which is 26 and p. And I just say, well, I know in order for this statement to be true, 26 must be equal to p. So if I replace this with 26, we would have a completely true statement in which one side equals the other. Now, let's go on to 82 because it gets a little bit more complicated because we got some algebra in it. I do the exact same thing. I say we have an equation in which one side must be set equal to the other side. And when I do that, I look automatically with logarithms. Are the bases the same? And I say, hey guys, look at that. They're both 20. Perfect. And since the bases are the same, all I really need to be focusing in on is the fact that 8 minus 2x has got to be set equal to negative 3x plus 10, because these two values have to be the same in order for this to be a true statement. At this point, just some basic algebra, that's all. So I'm going to subtract that 8 over to the other side, and that is going to give me negative 2x equals to negative 3x plus 10 minus 8 is just simply 2. And then I'm going to add that 3x over. And that is going to say, okay, 3x, negative 2x plus 3x is 1x equals to this cancels, and it gives me 2. Therefore, x must be equal to 2 in order to make this statement equal to that statement, okay? But we can go to Desmos. We can type this in and we can verify it. We love the algebra and we love being able to verify things on Desmos. So that's what we're going to do. I'm going to come in, I'm going to type in log base 20 of 8 minus 2x. And then I'm going to type in log base 20 negative 3x plus 10. And what am I going to look for? Boom, boom. I'm going to look for their intersection. Let's find out where that intersection happens. You can see, guess what? The intersection happens right there at x equals to 2 for the intersection. We are in great shape. That's how you use the property of equality with logarithms. Straightforward, cut and dry.